So on this, it says probability is a measure of something that's going to happen. For example, if I have a spinner and it is 1, 2, 3, 4, what's the probability, and you usually put it in a fraction form, of it landing on a 2? It's okay, but it's 1 out of what? It's 1 out of 4 because there's 4 sections. So usually a total goes on the bottom. What's the probability of it landing on a 3? 1 again out of 4. Now this time, what's the probability of it landing on a 2 or a 4? 2 out of 4. So it's going to be 2 out of 4, which is, we've got a 1/2 chance that it'll land on one of them. Here's a good one. What's the probability of it landing on a 2 and the probability of it also landing on a 4? 0, because it can it land on the 2 and the 4 at the same time? If it's a spinner, no. So this one is 0. 0 out of 4. There's no chance at all. So let's just look at a couple of these terms. It says theoretical probability can be defined by this formula: the number of outcomes out of the total, which we just did. Each number on the spinner is one possible outcome. So on this one, there's 1, 2, 3, 4, 5. And the sample space are all of the possibilities, which is the 1, 3, 5, 7, and 9. Then complementary events. Complementary events, I don't know if we're going to have to do that today. I don't think we will. 2 events is the event happening and the event not happening. So if they're talking about, I don't want to do this one on that because we're not talking about it. All right, so let's just go ahead and look through and see what we're going to do. So let's look at this one on your paper. So the first one, what's the probability? I'm going to switch that around. What's the probability, looking at this, of getting a 1? 1 out of how many? There's, yeah, let's start. There's 1, 2, 3, 4, 5, 6, 7, 8 altogether, and there's only 1 1. So it is 1 out of 8. What's the probability of not getting a 2? Well, how many are not 2s? Careful.
6, 8.
Yeah, because there are 2 that are 2. So there's 6 of them that are not 2. So this is 6 out of 8, which could be reduced to what? 3/4. Then, what's the probability of getting a 4 or a 6? So let's see how many 4s and 6s. So there's 1 6 and there's 1 4. So there's only what? 2. So there's, well, put the original first. It's 2 out of what? 2 out of 8. Which then, does that reduce? Yes. So 1/4. Okay. Now this one is, what's the probability? Again, this is an or, so we can do it. What's the probability of getting, I'll do them separately. How many 4s are there? 1. So I'm going to put a little 1 here. Or getting an odd. So let's see, is 2 an odd number?
No.
6 is not an odd number. Is 3 an odd number?
No.
So there's 1 odd. And then the next odd is a 5.
4 and 3.
Odd. And then the 3. So how many odds are there?
4.
So all together, what's the probability of getting a 4 or an odd?
5.
Add those up, it's going to be 5/8. Then, oh, here's a good one. Okay. What's the probability of getting a number that's less than 7? 8 out of 8. In other words, 100% of the chance you will get something that's less than 8. Or we could say, I'm just going to leave it as 8 over 8. All right. What's the probability of getting a number greater than 6? 0 out of 8. Or just 0. What's the probability of getting now, this time, just an odd? What's that, Gabriel? But you don't say half first. 4 out of 8. So it's 4 out of 8, which then reduces to what? 1/2. Then, now we're going to get an even or 2. That one I actually have to look up the answer because 2 isn't even. So I don't know if they're going to count it twice. I honestly have to look it up. So count all your evens first, and we might just count the evens, and let's see. So this is going to be, that's what I'm thinking. So we're going to see 275. I just want to confirm. I don't want to lie. So 275. So it's going to be, oh, is this compound events? Probability. Okay, it is half. Yeah, so you don't count the 2 twice. So the evens were 1, 2, 3, 4. So again, if it's something like this, you don't count that twice if it's already an even. So it's 4 out of 8, which is what? Which is 1/2. Then it says find the probability of each event, then find the probability of its complement. Its complement, for example, if I find the probability of getting a 1, its complement would be the probability of not getting a 1. So then it's easy. You just subtract. It would be 7/8. So again, if E is the probability of getting an E, its complement is the probability of not getting that E. And again, the probability of not an E, its complement is getting an E. So the number selected is 1 through 10. So let's write that. Let's write 1 through 10. Put 1, 2, 3, 4, 5. You should be writing this, Gabriel, on your paper. 6, 7, 8, 9, 10. Then, the probability of getting a prime number. By the way, is 1 a prime? No, because a prime number must have 2 different factors. And this only has 1. It has 1 times 1. Yes, ma'am? This is neither. This is the one that is neither. So the first prime is 2. Who knows the next prime? Again, you should have written this down, Mateo. This should be written down. The next one is 3. Who knows the next prime?
7 or 5.
5. The next prime is 7. The next prime is, that's it. So there's 1, 2, 3, 4. So, and let's double check our numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be 4 out of 10. And right now, I'm not even going to reduce it. So its complement, what's the probability of not getting a prime? 6 out of 10. So this is the not, the complement. Okay. What's the probability of getting a multiple of 5? How many are multiples of 5? The 5 and the 10, which is how many of those?
2.
So it's 2 out of 10. What's the probability of not getting a multiple of 5?
8.
It would be 8 out of 10. Again, we're not going to reduce these because it just is easier to work with them like this. What's the probability of getting a number divisible by 3? Which is what are the ones divisible by 3?
It's 3.
3. What else is divisible by 3? 6. What else is divisible by 3? And 9. So it's 3 out of 10. What's the complement of not getting a number divisible? 7 out of 10. And what's the probability of getting a factor of 10? Oh, that's a good one.
1.
Okay, well, what are factors of 10? Here, let's write them down. The factors of 10 are numbers that multiply together to give you 10. 1 times 10, you should write this down. What else is a factor of 10?
5.
Start with 2. 2 times what? 2 times 5. Is there any others? 3, 4, no, that's it. So it's what? 1, 2, 3, 4 of them that are factors of 10. 4 out of what? 4 out of 10. What's the probability of not getting a factor of 10? 6 out of 10. And I have the feeling, let me see if you have experimental today on this. I don't think you do. You're not going to have it today. Okay. Let me see. Find the experimental probability of each event, then compare it with the theoretical probability. Oh, I need to read this. Okay. So it says, we'll go ahead and look at it. So, theoretical. Where is? Yeah, the theoretical is our basic probability. But let's see what they're talking about experimental. And then I need to make sure we watch the time. All right, 1:38. Alrighty, so here we go. And so let's go ahead and see what it says. It says, when you find the probability of an event by doing an experiment, you will be finding an experimental probability. The greater number of trials that you do in an experiment, the closer the experimental probability gets to the theoretical probability. What? Let's look. Okay. So experimental probability can be defined by the formula. The number of times that you get that favorable amount out of the number of trials in the experiment. So let's look at this example and see. It says, a coin is tossed repeatedly. The results are recorded as 53 heads and 47 tails. Now, what is the theoretical probability of getting a head on one coin? So here's a coin. What are the two sides on a coin?
Heads and tails.
Heads and tails. So the theoretical probability of getting a head, how many heads are there out of the two sides? 1 out of what? Out of two sides. What's the probability or the theoretical probability of getting a tail? 1, again, out of, there's two different sides, out of 2. But now they're saying in the experimental one that they did, they tossed it all together. What's 53 and 47? It's 100. Okay. So, in fact, let's go ahead and look at this, what they did. So so here's the difference. The experimental one is you take the number of outcomes that you got for the heads. They flipped it 100 times and they got 53. So right here, the experimental would be 53 out of 100. And in fact, who knows what the experimental probability would be for the tails? Well, no, we don't name it first as a point. It's 47 out of, how many times did they do it? 100. So the experimental probability would be 47 out of 100. And we can put it in decimal later. I don't care about that. But what they're saying is the greater times that you do this, the closer experimental probability gets to the theoretical. In other words, isn't this almost a half? Yeah, like if I cut off that 3, it's almost a half of the 3 and the 0. So the more times they did this, the closer it got to half. And also the same thing here. If I just added 3 more times to the tails, it would have been a half. So this experimental one gets very close to the theoretical one. And that's what that means. And that's all. So let's see. We're not going to do this today because it's going to give me a headache. So let's see what you're going to do. I'm going to try to make it easy. And I think what we're going to do is we're actually going to start on this side because I ran this off and then I realized it didn't really relate to the one we were doing today, but we can do this. So now this is different. This is now you've got 2 different spinners. You've got this first spinner and the second one. So if you've got 2 things that are occurring, you're going to have 2 fractions. So I want to know what's the probability of spinning this once and getting a white. Who knows what's the probability here? 1 out of 5. So go ahead and write that down. 1 out of 5. Then look at your second spinner. What's the probability of getting an A? 1 out of 3. Well, here's how you do these. You get your single probabilities and then you just multiply them. So the probability that I'm going to get both of them is what? What? What's 1 times 1? 1/15. And if you need paper, you can get a sheet of paper. 1/15. And you're going to find your 1/15th, and I would just cross it out. Yeah, that's all you can do. Look for your 1/15th, and where is it? And cross it out. Okay. Then, who knows, maybe we'll just do this one. What's the probability of, okay, let's do the number 5. What's the probability of spinning it the first time on the first spinner and not getting a striped? Of not striped. 1, 2, 3 are not striped. So that's, in fact, I think I'll put it over here. We'll start it here. 3 out of 5. What's the probability on the second spinner of getting an A? 1/3. Okay, well then look at this carefully. You multiply them together, but what can I cancel out real fast? The 3. So do it over to the side. So my probability of getting them both is a 1/5 chance. It's not a very good probability. What's the probability right below of not getting a white? So I'm going to put it over here, 4 out of 5. What's the probability of getting an A? 1/3 again. Okay. There's nothing that reduces. What's your final probability? 4/15. In fact, I forgot to look for the last one. So 4/15. So 1/5 and 4/15. Here's 4/15 down here. And 1/5. It looks like they're putting all these ones right in the beginning. Right here. Are these pretty easy? Yeah. All right. Then, oh, here's it. Let's go down to this 24. Oh, by the way, this singular for this is a die. But on a die or dice, how many sides are there really? 6. You're not seeing them all. This cube has, you should write the numbers out. It actually has 6 sides. It has a 1, 2, 3, and then 4, 5, 6. 4, 5, 6. So now this one, they're going to spin a spinner, and they're going to roll the dice. So let's look at this one. What's the probability on the spinner of getting a blue? 1 out of 4. Then on the dice, and I try to say die, but I don't like that word. It's dice. Dice is plural, but I don't like to say die. That's really one. What's the probability of rolling your die and not getting a 2? People help me out?
5 out of 6.
5 out of 6. So I'm going to put it right here, 5 out of 6. Nothing reduces. What do you do with those two numbers? Well, we can't cancel, but just multiply. So what's our answer? 5 over 24, which is a very small probability that if I was betting money, I wouldn't bet because I've got a very little chance. So 5 out of 24, which is down here. And how you're going to do this puzzle is the letters that are left. You'll have 1, 2, 3, 4, 5, 6, 7, 8. Then this one here. Number 12, what's the probability of getting a red on the spinner? Careful. 2 fours. So read carefully. 2 out of 4. What's the probability on the die of getting an even number? Yeah, there's 2, 4, and 6. It's going to be 3 out of 6. Now on this one, can I reduce? In fact, I'm going to reduce, but aren't both of those halves? Yeah, so I'm going to reduce it over here. It's 1/2 times 1/2 is what? 1/4. So my final answer is 1 out of 4. I don't know. And there's 2 fours, you just cross off one of them. It says, if an answer appears more than once, it doesn't matter which one you cross out, but just cross out one of them. And so do you kind of understand how to do those? Okay. We'll go down to this one. Here's this bag. You've got 1, 2, 3, 4, 5, 6 marbles. You're going to pull a marble out of the bag, but then you're going to put it back. So each time you pick, you're going to have 6. There's one later on that we don't replace, but today you will replace it. So look at this one here, the number 18. What's the probability that you draw the first time and get a black marble? 1 out of 6. What's the probability? Now you're putting that marble back, so you still have 6. What's the probability that you get a striped? 3/6. And now can I reduce? So 3 does go into 6 2 times, and your final answer is 1 over 2 times 6 is 2 times 6 is. Okay. We did right here, the 3 and the 6. We made it a 2. Okay, so let's go down to this one. Okay. The number 24. What's the probability of drawing the first time and not getting a white? 4/6. So please put your original numbers. Don't reduce it in your head. I need to see what that real probability would be. Then what's the probability? The marble's going back in. What's the probability of not getting a white again? How many are not white? 4/6 again, because we're putting the marble back. So now we have, again, the same amount of marbles. So 4/6. And then on those, can both of those be reduced to 2/3? Yes, no, maybe? Yes. So I'm going to put 2/3 times 2/3. What's our final probability? 2/3 times 2/3, because that's 2/3 times 2/3. What's our final answer? 4/9. 2 times 2 is 4. 3 times 3 is 9. So there's a 4/9 chance, and that's a little bit better because most of them are not white. So 4/9 is right here. And then we're going to look at these 2 word problems, and then I think we're going to call it a day. Yeah. So let's look at these 2 word problems really quick. What's the probability of guessing the correct answer to both questions? So there's 2 questions. So I'm going to put over here 2. A test has 2 multiple choice questions, each of them with 5. So I already know my bottom number is 5 on the first question and 5 on the second one. What is the probability of guessing the correct question? Well, how many answers do you get to choose? 1. So the first one is 1 out of 5. What's the probability on the second one? How many do you get to choose? You get to choose 1 again. So what's the probability of choosing both of them correctly? 1. What's 1 times 1? 1. What's 5 times 5 people? 25. So again, you don't want to guess on a test. You've got 1/25th chance, 1 out of 25, that you will get both of those correct. Okay. And we'll do this last one, and then I know exactly what I'm going to say. So this last one is, what's the probability that both letters are vowels? So one letter is randomly selected from the word math, and then a second letter is randomly selected from the word jokes. What's the probability that they're both vowels? So on this one, how many letters does the first one have? So it's going to be out of 4. How many letters does the second one have? It's going to be out of 5. How many vowels are there in math? 1. So it's 1 out of 4. How many vowels are there in jokes? The O and the E, so 2. Can I reduce 2 and 4? And that's going to be a 2. What's our final probability? Is 1/10. Okay. Your job, people, is to finish up this page. That's it. Just this one page. Yes.